Could you see my screen?
Yep, whenever ready, go ahead.
Yes.
Mm, mm. Okay, hello everyone. My name is Ali Fathi, and I'm here to present my capstone project today. So my project is simulated robotic arm control for intelligent task assignment. So I'm a master student of computer science, and the instructor for this project was TJ Kim, and the course number is CS 687. So here's the agenda for today's presentation. We're going to start with introduction and exploring the problem statement, and then moving forward to motivation, background, and related work. And we're going to see how the approach and design and implementation works. And after that, going through the data collection and data analysis and finding and results, then conclusion, and see how the future works going on. So as a robotic system becomes more common in areas for industries such as manufacturing and logistics and healthcare, the ability to simulate test robotic control system without the need for costly hardware becomes increasingly valuable. This project aims to develop a simulate robotic arm that can receive and execute task assignment using inverse kinematic. The simulation includes a backend API for assigning tasks and a visual component to demonstrate motion planning. By focusing on realistic control logic and visual feedback, this project will serve as an educational purposes and for developers to gain the knowledge and work on their project. So as you can see, the robotic system is crucial and dependent physical hardware. It was really one of the most things that at the first I was facing, that the hardware are so expensive that you need to find something to replace those things. So backend, the system uses like a different variety of sources like fast API as a web backend, NumPy as a mathematical calculation, including trigonometry and matplotlib library for 2D visualization. Real-time visualization, the way this simulation does. Our project fills this educational gap with using the Python Jinja 2 for rendering HTML, and Unicorn runs the server. Python is the core language known for its readability and wide use in robotic. So let's go to the next slide, which is related work. So research by Zhang and Wang and others has focused on improving inverse kinematic and deductional tools. However, few projects combine accessibility, web interactivity, and real-time visualization. The way the simulator does our project fills this educational and practical gap. So as you can see, the studies of Zhang and Wang, Hassan and Mohammed, and Lee and Sun, that they're working, each project working on different aspects of robotic arm simulator. So one working on inverse kinematic approach, the other one working on simulation design, and one other working on just visualization, task assignment, and mechanism, learning outcome, and techniques and technologies and um, stacks and other things. So the approach we followed is agile Scrum with weekly sprint. So which is means focusing on modular testable components each week. This kind of approach helped me to build the simulator iteratively with full stack integration, from user input to backend logic to real-time visualization. So, and on the next slide, which is this one, you could see the difference between the studies that I used on my research paper versus the things that I done in my research paper. So you could see, for example, Zhang and Wang at the inverse kinematic approach, the precision inverse kinematic for serial manipulation runs with advanced algorithms. So, and I use inverse kinematic for upload a 2D real-time web browser. And there is some other differences between the studies that I use as a resource and the one that I use in my research paper. So let's go and see how our research design works. So the simulator uses a two-link robotic arm model. It calculates joint angle using inverse kinematic and updates the display in real time. So it means the back end handles HTTP requests, with the front end gives user a simple interface to input coordinates and views results instantly. So far, anyone have any question? I don't want to just presenting all the things and make it like so boring. If you have any question, you could raise your hand and I'm so welcome to answer your questions.
Makes sense so far.
Okay, sounds great. So let's go to the next slide, implementation. So the implementation combines Fast API with NumPy, Jinja 2, and Matplotlib library when user enters coordinates. The system calculates joint angles and visualization the arm's movement. So it deploys locally with Unicorn and smooth asynchronous operation. So as you could see in the diagram, user puts the input and the HTML and Jinja templates, sends the templates with Fast API to Matplotlib library, and it constantly shows it on the web browser. So on the next slide, we're going to how we approach to gain the data. Every user put their input and interaction, whether through the API, is going to logged in a CVS file. We track coordinates, joints, angles, successes, flag, timestamp, distance, data for both validation and future improvement. As you can see on the next slide, this is how we're going to log our data. So it's gain the time, it gains the coordinates, theta 1, theta 2. It's going to be from API or form, and it's going to be like, does it going to be successful or not? If it's successful, it shows true, or if it fails, it's going to be fail. So we analyzed 66 valid submission, the KDE, the kernel density estimate heat map shows that clusters user inputs areas that our system is both fast and accurate, and most responses were returns in under uh, 0.05 second with high re- reliability. So as you can see in the heat map, this one is shows the position of coordinates, and the next one is going to show the execution time versus distance error. So it shows a very small difference on the execution and distance error. At the next slide, we will see the distribution of execution time by submission success. So this means that how long does it take that the web browser from when you put the coordinate till the execution time. So results. Let's go to the next step, which is result. Uh, so the application shows the high precision of responsiveness. The simulator successfully computes inverse kinematic and updates the interface instantly. It's user-friendly and adaptable for both beginners and advanced use. So, as in conclusion, we built a modular browser-based simulator that effectively demonstrates robotic control using inverse kinematic. It's efficient, scalable, and offers hands-on educational experience without requiring physical hardware. So our future work's going to add a 3D simulation support, smarter input handling, and machine learning intelligence for trajectory planning, and even connected the simulator to real-world robotic hardware for live demonstration. On the next slide, I'm going to play a video which is shows a demo of my project, and it has more to go, but I think right now it's just like really on the really first pages that needs to work on it more, and it has the capability and adaptability to use in the future work for educational purposes. Let's go and see the demo together.
Hi, Ali. I think we're out of time, and thank you for your presentation. And we can entertain 1 to 2 questions.
Okay, it's these ones are reference, and if anyone has any question, I could answer the questions.
Yeah, I'll give the first question. I'm not really into robotics, but I've like researched a little bit on like digital twin. Is this in the realm of like doing digital twin?
Sorry, your voice is so not good. Could you please repeat your question?
Yeah. So my question was, is this in the realm of like digital twins?
Oh, not actually. So the basic things that was this one use inverse kinematic and shows you how the arms movement. So right now it's working on the 2D version of the robotic arms, and I'm working on the changing 2D to 3D one, so that you could use and enjoy the 3D placement of the robotic arm and see how the movement does work. Does it answer your
Oh,
question?
yep.
Okay,
Any other
sounds
questions?
great.
If not, we'll move on to
Yep,
the next
yep.
presenter,
I have a quick
Yes,
one.
Veronica.
yeah,
I
for
was just
sure.
wondering when you go, when you proceed to the 3D model or simulation versions, do you foresee any problems with performance bottlenecks?
Yes, I see difficulties in the movement of the arms right now, because the placement of the version of the space that we need to use as a 3D is kind of difficult. I'm personally new to it, so making a 3D version of places of X, Y, Z, it's kind of difficult for me. But at first, uh, making it without any movement was easy, but if you want to move the arm, it's kind of difficult. So, yep, right now I'm seeing some kind of difficulties.
Sounds good.
Yep,
Thank you.
thank you for your question. Okay, hopefully you guys enjoy the presentation. Thank you.
Thanks, Ali. We can move on to Sangeeta. Yeah, Sangeeta.
Yeah.
And whenever you're ready, go ahead and present. Thank you.
Yeah. Can you see me? Hello.
Yes. Yep.
Yeah. Hi. Hi. Good afternoon, everyone. I am Sangeeta Bukya. I'm from India. Um, and today I'm excited to present my project. I mean, like capstone project. The project is about the FinSense and AI powered personal finance companion. It is like helpful for every individual to gain a better control over their finances, like in for the real time insights and like intelligent recommendations. Okay, and coming to the agenda, we have like problem statement, motivation, background, related work, approach, design, implementation, and like conclusion, findings, future work, and the data collection. Going on to the next slide, it's like problem statement. Coming to the problem statement, many people struggle with managing their like financial, personal finances, due to which they lack in the real-time information and like tailored guidance. For this, along budgeting tools alone are like not often static, and without personalized advice, users tend to make poor financial decisions. So, according to the Smith 2022, which that leads to weak financial discipline and ineffective financial planning. It show in the, I mean, it's like a, what do you call it? According to like the research, it shows like in Smith 2025, 20, sorry, 2022. And coming to the motivation, the motivation behind FinSets comes with two major challenges. And the number one is like raising difficulty in personal financial management. And the number two is like high cost of financial illiteracy in terms of debts, poor saving habits, and missed opportunities. While there are financial literacy initiatives, they often fail to provide like personal guidances, and like John Slay 2022 emphasized the importance of contextual and tailored advice, which in sense aims to provide through AI. I mean, like this is done with the help of the AI. And coming to the background session, um, Pinsons is built using the MERN stack. MERN is like the meaning of the MERN is uh, it's used with the Mongo, React, Express, and Node. I mean, the MERN uh, abbreviation stands for. MongoDB is for flexible and secure data storage. Express and Node is to manage the backend APIs, and React is for dynamic and interactive front end. Actually, this project consists of like three parts. One is like front end, back end, and the dashboard. And yeah, um, coming to the related work, FinWise is like they have intelligence, guidance, user engagement, analytical capability, approach, and tech stack. And they are like IFAC's findings and design partners. Coming to the approach, yeah, it's like approach. Mm, our system follows a modular architecture consisting of key components. The app component manages routing and user authentication. The dashboard visualizes income, expenses, and savings. We have like three parts. Like the dashboard includes income, expenses, and like savings. The expense manager lets user add, edit, and like track transactions. The budget planner helps user to plan and manage their monthly budgets. And AI Insights delivers personalized forecasters and recommendations with that. This global state is managed through a centralized store and ensuring consistent data flow through components. Like, yeah, this is the process it go through. And like coming to the design, as I said, MERN stack is used for user interaction. Using this MERN stack, we can manage both user interface and data storage efficiently. Mm, all expenses all expenses data is stored securely in MongoDB, and a separate Python script runs AI-based forecasters. And also like what you call AI-based forecast is handled by a separate Python script. Yeah, that's what. By using PyMongoDB and Python script. This hybrid approach follows for both flexibility and scalability. And the next slide is like implementation. Implementation is like it works like a user entered data like income, expenses, and savings is corrected via interfaces such as the budget planner and expense manager. They are stored in a MongoDB in like real time. The data is fetched and pre-processed dates and converted to a numeric values for time series forecasting. Python through pandas and number system process this data. Like we use feedback profit or reboost time series and forecasting models to predict I mean like uh, future expenses. And the like data collection, yeah. It drives through AI predictions and like visual summaries. And like coming to data analysis, pandas and NumPy were used for cleaning and pre-processing. Prohent, I mean like we used to generate expense forecasters. So we used ChatGS and rechats in React. to visualize the information on the graphs like which are showed here, which is like showed. It takes like amount, what are the amount the expenses is going on, and like according for certain time like 30 days or like 60 days, depending upon the time period, it forecasts is the expenses and the what you call, and the plannings, everything. Coming to the findings, like some of the key points, key outcomes from our implementation is that the dashboard visuals improved financial clarity for user by making partners obvious. It's like expense categorized helped in identifying overspreading areas, and also like the budget planner increased user engagement by helping set and track financial goals. Most importantly, the AI-based insights provided users with smart and personalized advice, something static apps like often lack. Hmm. Is all okay? Yeah. Excuse me. Do you have any queries in between? Okay.
For me, I don't really have queries, but is there
Yeah,
any more
yeah. I'm
contributions,
going
or are
ahead.
you
Yeah.
done?
Coming to the conclusion, like the FinSense was developed to meet the growing need for intelligent and real-time financial management tools. It addresses the lack of predictive and analytical platforms in in personal finance. Our key innovation lies in integrating and proferent model, like which predicts further expenses based on their historical patterns. Yeah, and this allows, because in general, like this allows user to anticipate their like financial further and make informed, confident budgeting decisions. Yeah, and coming to the future work, excuse, coming to the future work. It's like looking ahead, we can plan to implement secure user authentication for like better privacy, and also improve forecasting accuracy by collecting and training at large data sets, and also like explain the app into a full AI powered financial advisor, like to capable of, so that it will be capable of managing investments, loans, and saving goals also. Basically, the project, I mean, it consists first of all, the data is set up by data collection. Like we will predict further expenses based on the past spending data, so that the Python script connects to a MongoDB. It reads data from the expenses collection, and each record includes amount and the date. As I showed it in the graphs previously, it takes amount and the data to forecast. And also, and come next, the script converts the data field into a numerical value called days, so that it will this is a machine learning language needed, so it will convert into dates, and then like 0 1 2, like that. Next, the coming to the model selection, it's like a linear design resignation model is chosen. It is like simple and fast. It tries to fit a straight line through the data, uh, yeah, it graphs it like it takes according to the expenses and dates, how, and the category also. It takes categories like how much amount you spend, like how for how long, and like that. And the model is trained by using like inputs and outputs like X and Y form. And also the script generates values for next 30 days. It shows off in the before itself. Mm, next, yeah. Yeah, I can show you the demo, but I'm not sure. I I like probably I did not know, didn't get to know like how to record, but I tried to record it through the phone. I'm not sure you people can see that or not. Like what? Yeah, here you can like put the data like in the data and the CD so that it will take the category and the expenses. After this, it will redirect like as a graph and the categories. So for example, it's like you have spent $100 for transportation, and for like groceries, you have like spent $500 on certain days. It will show in separate what you call categories, the graph bar charts, and by yeah, the this one, the expense categories like that, so that we can have like a have a look of like how we are spending and like how we can manage and like plan according to that. Yeah, I probably shared the demo to the instructor also, but I could not now I mean record it like properly. Yeah, that is the budget overview, and here we can add the expenses and forecast it.
Hi, Sangeeta. Time to wrap up. Thanks for the demo.
Yeah.
And if I may, can I open the floor for questions? Hello.
Hello? Yeah, go ahead.
Uh, okay, so I'm curious if there's like any future plans to integrate it with like third-party APIs, maybe through email or I don't know, Venmo, Bank of America, so that it's easier to pull data and then predict.
Yeah, we can actually try that also. I mean, but as of now, it's like only manually entered data collection. In future, we can do it like that also. I mean, like it also helps in like apps designed. Hello?
Okay, yeah, thank you.
Yeah, thank you.
Any other
Thank you
questions
for
from
the
the
opportunity.
audience?
Yeah, yeah, yeah. Thank you for the opportunity, and I'm happy to take a part of this.
Oh, thank you. Thank you for
Yeah,
your work and presentation.
thank
If
you.
no one else, let's move to Eric. Thank you.
Yep, 1 second. I'm just gonna get my presentation set up. Second. Sorry, 1 second. My presentation is going on the opposite screen of where I want it to go. Okay, I'll just do it from this screen, and I might have to look over at my other screen. Okay, can everyone see it okay? Hello?
Yeah.
Oh, sorry. Let me put my camera on too. Okay. Okay. Welcome to my
Hey, Eric,
presentation.
right now I think I can't see your presentation right now.
Oh, you can't? Oh,
I
sorry. I think
I
I
could see
accidentally.
you, but yeah, but not the presentation.
Sharing the screen.
I might have accidentally turned it off. Okay, sorry about that. Good to go now? I can't see the team screen. Okay, cool.
All good.
All right, welcome to my presentation for securing fire integrations. This is specifically related to automating the JWKS endpoint exposure in the cloud. I'm Eric Gainey. This is my final presentation for CS 687, the Computer Science Capstone for Spring 2025, Masters of Computer Science, and my professor was Professor TJ Kim. Quick agenda. We're going to go over the problem statement, motivation, background, related work, approach, design, implementation, data collection, data analysis, findings, conclusion, future work, and key references and questions. Problem statement. So the problem statement is, how can we design an automated cloud-based process to expose and rotate JWKS endpoints for fire applications, ensuring that JWT validation remains reliable without manual processes? So some of that might sound a little foreign. It's kind of a niche environment, but we'll dive into it a little bit more. So many healthcare applications use FHIR, which stands for Fast Healthcare Interoperability Resources, and secure their API calls with JWTs, JSON Web Tokens. Those require a public key to be available to validate the private key as a form of authentication. A lot of systems today that are pretty early adopters in FHIR and the process of exchanging healthcare data through this method are pretty early in the process, and a lot of times they have manually hard-coded public keys in solutions and manually created pages where they host their JWKS endpoints for their different clients to retrieve their public keys. Obviously, this is not ideal, and it can create operational risk, especially in regulated environments where misconfigurations can lead to security breaches or authentication failures. My motivation, so FHIR is being adopted more broadly, mainly due to regulatory pushes from organizations like the Center for Medicaid and Medicare Services, CMS, OAuth with OAuth 2.0 with JWTs has become the standard authentication approach. There are some older methods of authentication that are still allowed, but that is the primary approach, and that is what the official HL7, which is the governing organization of this design, is trying to encourage everyone to do because it's the most secure. And again, many organizations are still manually doing the different processes and using those older methodologies. So this project is kind of to serve as a push in the right direction to help people out when they're trying to do their implementation. So background to make it make a little more sense. So the tools I used are Azure Key Vault, Azure Function, and OAuth 2.0, at least the major tool. So why use these tools? Azure Key Vault centralizes secure storage of cryptographic key certificates, and that eliminates the need to hard code the secrets. It offers role-based access control, or RBAC, as well as managed identities for secure access. It provides us with automatic key rotation and auditing features supporting long-term security compliance, and it ensures the private keys remain protected, which is one of the best practices from for OAuth 2.0. Azure Functions enables serverless architecture, scales automatically with demand, provides lightweight HTTP accessible JWKS endpoint for public key retrieval using an HTTP trigger function that's already built in when you hit the endpoint. And then it simplifies deployment and versioning for small services. The Azure functions are super lightweight, and it supports binding directly to other Azure services like Azure Key Vault. So we can use managed identities to access the Azure Key Vault, which is 100% Microsoft designed and supported as being a secure access method. A little bit more on background, just to bring you in on FHIR. FHIR is, I already defined it, fast healthcare interoperability resources, and that's the current standard for API-based healthcare information exchange. So it's very similar to JSON, but a little bit different, and everything is structured into resources that are interconnected, kind of like the relationships between tables in a database. To securely authenticate to these APIs, we use the JWTs. That's the preferred method, at least. And that verification depends on the public key being accessible at the endpoint. A JSON web key set is just like any other JSON payload you would expect to see. And each key is structured in the overall JSON web key set, and you can pick out each key by parsing the JSON payload and all of the attributes that are associated with that key. We'll go into that a little bit later. Related work, so I did some comparisons between some of the works. Like I said, this is pretty new, early adoption, so there's not a lot of specific examples of other people doing this, or at least sharing their work. So I just related my key references for HL7 International, which is the governing organization for the FHIR design, Grassi et al., which is NIST, National Institute of Cyber or Security and Technology. I think it's a paper they published regarding certificates and OAuth 2.0, and then CMS Rule 0057F is a mandate that they published that sets requirements on both hospitals and insurance payers and several other healthcare entities, and requires them to adhere to some of the data availability rules using FHIR. So some of the key themes among these three references are let's see. Yep. So three key takeaways. The security standards and regulatory mandates require strong key lifecycle management and TLS secured, transport layer secured, JWTs, and live JWKS endpoints. Operational challenges of manual JWKS handling includes reliance on error-prone manual processes, lack of implementation guides, and inability to scale with growing FHIR clients, something that the Azure Functions provides us with. And the move towards automation shows that cloud patterns and serverless functions can deliver low downtime JWKS rotation and continuous compliance at scale, meaning when we rotate our certificates, it's instantaneous, there's no downtime, it's immediately available on the very next retrieval. And continued, we have two more topics: integration and discovery, monitoring, logging, and auditing. For integration and discovery, we show a pattern of defined JWKS format, which is highly specified, and also availability, so that it's available to integrate into external systems. It has to be open ID. It can't be hidden behind any security or authentication. It has to be 100% a public endpoint. And monitoring, logging, and auditing shows the both operational and regulatory requirements needed for detailed logging for both auditing the system functionality and the use of the system. For the approach, just real quick, it just covers the implementation of the key vault. It shows the basic flow through the design, and then also we will cover an implementation plan, which is highly summarized for this, but this is the design, generally speaking, not necessarily the code design, but the overall system design of a functioning FHIR authentication process. So when you look at a mermaid diagram, you start at the top and each bar you follow it over to the next one. So the data retriever goes to the key vault. The data consumer data retriever is the system that is going to request data from the external data system. So it has to retrieve the certificate from the key vault. It signs a request, a post request for a token, and sends that to the auth server. So that would be my other system that I'm trying to retrieve data from. And it signs that token with a client assertion. That client assertion contains the key ID and the private key. So it's got the information needed to recognize it. The auth server, the IDP, then requests the public key from the JSON web key set. Remember, it knows which one to go for because of the key ID. The JWKS system then retrieves the current public keys and returns all of that information in the JWKS endpoint, and then it's returned to the auth server. Once the auth server now has my client assertion and my initial token request, and which has the private key and it has the public key from the JWKS key set, it can do its own validation to assert that the public key matches the private key. So that validates my identity because no one else should have that private key but me. And then it returns the original access token requested if that validation is successful. From there, the data retriever, data consumer can now post or use the APIs that the auth server, beyond the auth server that the system provides to get the patient data. For the implementation, we store certificates in Azure Key Vault. We deploy an HTTP triggered Azure function, and we use managed identity for secure access from the function to the Key Vault. And once we have everything set up, we register the endpoint with the identity providers. That's very brief. I'm trying to be quick. Yes. Yeah. Data collection. So we just use the built-in functionality that Azure has for telemetry data. It automatically captures, well, with a little bit of configuration, key performance metrics such as execution time, response latency, success rate, and errors. And the Key Vault interface reveals all of the certificate lifecycle events for auditability reasons. For data analysis, like I said, the Azure tools provide real-time analysis through App Insights, so we can see performance and reliability, and we can also audit all interactions with the system, including the backend system's error logs, so that we can easily respond to it. It also provides something that Microsoft has developed called Custo Query Language, or KQL. It gives you default scripts to query these so that you can see trends like in the chart on the right side of the screen. And you can also modify these. It's a pretty simple language, somewhat similar to T-SQL or normal SQL. Findings. So to test the application, because I don't actually have anybody that's I'm requesting data through that would use my JWKS endpoint, I wrote a C# console application that just pinged the system 771 randomized requests over 2 hours, and it pinged the 3 different certificates that I had in there at random. So the Azure App Insights captured key metrics, average latency of 315 milliseconds, a max latency of 2390 milliseconds, which is typical due to cold starts when a function first fires up after not being hit for a while. And then it also had a 100% success rate. So there was no failures in that 2-hour period. And the audit logs for the Key Vault access showed 100% availability, no failures retrieving any of the certificate values, and an average latency of 43.3 milliseconds over the 2-hour testing period. And the chart on the right is one of the automatically, well, slightly tweaked, but mostly automatically generated charts that you can get through the application insights. The conclusion, manual JWKS management poses risk and adds operational complexity. This solution delivers a scalable solution with Azure ensuring reliable, up-to-date, accessible key materials. Azure Functions and Key Vault work together to ensure the latest public key is always available to clients without having any manual updates. There was 0 failures and an average latency of 315 milliseconds. And once the system is implemented, it reduces operational burden and enhances system reliability because we don't have to worry about a developer or a system admin introducing issues through improper configuration. Future work, things I would like to do to enhance the system. I would like to build mock systems to enable full end-to-end testing rather than just pinging the JWKS endpoint. I would like to build a mock data system, an IDP and auth server, as well as the full request for data that generates the client assertion. That way I could run all solutions at one time and it would be the full FHIR authorization process. I'd like to publish an ARM template for faster adoption. So in Azure, you can build an ARM template with the automatically creates the function, the key vault, and all configuration settings for App Insights. And you can just run that in your Azure environment and it automatically provisions everything. So that would certainly help other healthcare systems to adopt this solution. Replicating the solution on other cloud platforms, because not everybody uses Azure. I think it's pretty common in healthcare, but AWS and GCP, Google Cloud Platform, are other options that we could replicate the same behavior using their similar systems, and add caching and throttling for better performance. So here's my demo. I'm not sure how much time we have left, but I'll go ahead and play it. And here's my key references. Does anybody have any questions?
So Eric, so was it hard to use the Azure portal to do your JWKS?
I don't think so. I actually, the Azure portal, the more time you spend in it, the um, easier it is to navigate. It definitely can be overwhelming the first few times you get in there just because there's so many options. But just for this project specifically, it's actually really simple, and Azure does so much of it for you that it makes it really easy. And specifically using C# and Visual Studio, publishing to Azure, if you're using the same account that has access to the Azure portal and the subscription, you can push your code directly to the Azure function just by clicking it in the GUI.
Nice.
Mhm.
So you mentioned a while ago about the complexities of the GWKS, right? Like, um, do you know anything more specific in terms of like trying to go to that more secure route? Let's say you already have JW tokens, right, and you're moving to the JWKS. What other hurdles that developers or implementers would have, like security engineers?
So the biggest thing is a lot of Azure uh, instances for companies have firewall rules and other security measures in place that prevent traffic from coming in. And that goes for if you have a server built on your internal network, on your intranet network for your company, you have to be able to allow traffic in. Like I said earlier, it's open ID, so it has to be completely available, no methods of access control for actually calling the JWKS endpoint. So what a lot of people end up doing, at least currently until it's mandated otherwise, is they just use client credentials, so client ID, client secret, to allow people to call that endpoint. But this method is more secure because as long as you keep your certificates under lock and key, then there's no chance of it being compromised. Um, and you could say the same about credentials, but credentials are a little bit, less complex than a high algorithmic, high encryption level certificate. But the biggest hurdle I would say for companies looking to implement this would be to, in their Azure instance, create the correct firewall rules to allow traffic to come in through, into a DMZ, a demilitarized zone or something like that without letting them fully into your Azure instance. But Microsoft makes it a little bit easier than I think if you tried to let someone into your actual intranet, on your actual network would be a higher risk in my opinion.
Thank you, because I have experience like working as a software engineer, and for us, security is a pain, and we always just use the service account, client secret, client ID, and if
Yeah.
not, get the bear token. Uh, so hopefully, security would be more streamlined.
Yeah. Yeah. Security is always a hurdle.
Any other questions from the crowd?
So I have a question, Eric. When you choose the things that you use in the Azure, so before that you're going to use, for example, Azure Key. The tools that you're going to use from the Azure, or you try and like use other tools in the Azure and figure it out that those ones is related to your project.
No, I had a pretty good idea that it would work. I've used Azure Key Vault before, and I've used Azure Functions before for different solutions. Um, I know Azure Functions are extremely lightweight, but they are also pretty versatile. There's a bunch of different types of triggers some that tie into specific Microsoft processes, like Azure Blob Storage. You can have a blob trigger, so every time a file gets uploaded, it does something. HTTP trigger, every time that API endpoint is called, or if you go to that URL in a browser, it triggers that function to do whatever you've programmed it to do. So I knew it was lightweight, but I knew it also had the capability to scale to a very large capacity, which makes it kind of perfect for this. And then Key Vault is Microsoft's de facto lean to for anything you need to store that's secure, whether it be, credentials, files, certificates, anything really. So I've used both tools in the past, and I knew that it would be suitable for this solution.
Thank you so much.
Mhm.
Okay, that's a wrap. Thank you, Eric, Sangeeta, and Ali. Thank you for your great work, and I hope you have a successful, next step in your career.
Awesome.
Thank
Thanks,
you
everyone.
so much.
All right.
Thanks.
Thanks everyone
you.
for presenting today. Yeah, if you guys want to go, I don't think you really need to go back to the main session anyway. Anyway, thank you everyone. Good work. We hope to see you around.
Thanks. Have a good night,
Thanks.
everyone.
Yeah, you too.
Bye.
Thank you and bye everyone.